So, good afternoon, students. I hope my screen is visible to you. I hope my voice is also audible to you. Yes. Good afternoon. See, I gave a big good afternoon and only 2 people could get back to me saying good afternoon. Okay. Others are all sleeping. This simple question also you guys are failing to answer at 2 o'clock. Okay. Now it's fine. Now it's fine. Okay. So let's go. Let's move ahead. So the bad news for you guys is this, that I have given you an assignment with 5 questions. I am expecting that this work will get done by tomorrow to be submitted. By tomorrow. Please send it to SDG at itself. Have little patience and work with it. It will come there itself. Now don't put messages to me, then it will become very poor. Okay, only 5 questions I have put. So please make sure that you have answered. Then I hope you all are understanding something. Then as far as our syllabus is concerned, whatever we have read mostly is there except for cyclotron. Then again, electric field due to a charged shell, that concept. Other than that, mostly whatever we have learned is there. A lot of changes are there in the future chapters. So accordingly, especially the next chapter, at least they have cut it down by half. So we will move on. Similarly, nucleus has been cut down by quite a bit. I thought they could have cut out on that semiconductors chapter, but they didn't. So we'll move on. So in the last class, I explained to you the working of a moving coil galvanometer. Then after the moving coil galvanometer, today we have to go and we have to read Biot-Savart Law. Okay, Biot-Savart Law. So we have to read the Biot-Savart Law. Okay, so we will all try to make some notes and then we will work. First, Biot-Savart Law is an experimental law. Experimental law means somebody did an experiment, and based on that experiment he has come up with a law which is called the Biot-Savart Law. What is it that we are going to read here? The basic concept here is that if you have a magnetic compass, if you have a magnetic compass near a current carrying coil, the compass showed a deflection. This was something which was observed by Ørsted, and this is what is the next thing that we are going to learn. So in the previous section, we learned that if you have a current and if you place it in a magnetic field, it experiences a force. Now we are going to learn that if you have a current, around it, there is a magnetic force. Okay, now this is something which Einstein explained quite well. What Einstein said, that if you have a charged particle here, at this particular point, there is an electric field. If you have a charged particle here and if you make the charged particle move, at this point, you will have a magnetic field. A moving charge is nothing but a current. Then Einstein further said, you make this move and you make this move, then you don't see a magnetic field, but you see again an electric field if the velocities are the same. Then Einstein said, okay, you don't move this, but you move this in this direction and you again get a magnetic field. So the fundamental concept here is whenever there is relative motion, whenever there is a relative motion between a charge and an observer, a magnetic field is generated. A magnetic field is experienced. Okay, now this part of the studies is a very, very important part, because now this part led to the discovery of electromagnetism. That is, passing current creates magnets, and the moment people discovered electromagnetism, the next thing they started making powerful magnets. Now what powerful magnets did is that it also kind of fueled the industrial revolution, wherein now a lot of work which was being done manually is now being done by these electromagnets. So when you want to work on huge boulders of huge sheets of iron or huge sheets of different types of materials, then yeah. Okay, so yeah, we need to learn. See, I will tell you, my dear students, don't worry about what is there in syllabus, what is not there in syllabus. The JEE exam next year may be postponed by 1 month or 2 months, and everything will be included. Okay, a lot of these things, they have removed forces and Newton's laws from your syllabus. So tell me, without learning about forces, so now that word force is not there in your syllabus. So do I say electric force, or what do I say? Do I say gravitational force or not say? Do I say magnetic force or not say? Because force is not there in your syllabus, right? So it's a complicated world. Don't worry about it. Just keep moving. So yes, you must know everything. Sir, will compasses of our mobiles show similar deflection when kept near a current carrying wire? It should show. It should show. Compasses on the mobile are not based on that. Compasses on your mobile will not show, because they only can detect the Earth's magnetic field. So there is a program for that, how they do it. But yeah, if it can detect a magnetic field, then it can. Yes, slowly we are getting into electrodynamics. Yes, now we are in electrodynamics. So we have never analyzed electrodynamics, only now we are beginning to analyze electrodynamics. That is, what happens when a charged particle moves. So the first thing that we understand, when a charged particle moves, is a magnetic field is generated. And okay, there is one last question. So will compass of our, no, but you can check on the way, on wherever you see those high tension wires, there is current. You can keep your mobile phone compass and then check. But if you have a good compass based on magnets, then it will definitely show deflection. Okay, so that is not important. So the important thing is that we have to read. So whenever there is relative motion between a charge and an observer, a magnetic field is experienced. So here the word relative is very, very important, and this is perhaps one of the most important aspects of Einstein's relativity theory, Einstein's relativity concept. So even though they did not give him a Nobel Prize for this, they gave him a Nobel Prize for his discovery of photoelectric effect. But I think this was more revolutionary for the physics branch than the discovery of photoelectric effect. Anyway, we are all small people. Our idea is just to sit down and learn. So let us learn. So the concept that I am going to teach you now is Biot-Savart law. It's an experimental law. So this is it. Suppose there is a wire going like this, which carries a current. Suppose you are at a point P. So point number 1, a current induces a magnetic field around it. Okay, then this induced magnetic field is proportional to A, the length of the wire, B, the current through it, C, sine theta, D, inversely proportional to R square. Okay, so I can say dB is proportional to I dl sine theta by R square. The constant of proportionality is mu naught by 4 pi. Yeah, so dB is equal to mu naught by 4 pi I dl sine theta by R squared. This is called Biot-Savart law. So this is R, that perpendicular distance is R. Now this is dl, so this induces a magnetic field here. Yeah, dB is equal to mu naught by 4 pi I dl cross r cap by r squared, or dB is equal to mu naught by 4 pi I dl cross r by r cubed. This is the vector form of Biot-Savart law. Here I have used r cap, here I made it r. Yeah, so if you can make a note of it, then we can slowly move ahead. A current induces, the word is induces, the word is not generates, nothing. The current induces a magnetic field around it. So as long as there is a current, there will be a magnetic field. If there is no current, there is no magnetic field. A current induces a magnetic field around it. This induced magnetic field is proportional to the length of the wire, the current passing through it, the sine theta, where theta is the angle between dl vector, theta is the angle between dl vector and r vector. This is r vector. Okay, dl vector is a length along the direction of current. dl vector is a vector along the direction of current. Okay, so these are the different forms in which Biot-Savart law can be written. This is the scalar form. So this is the magnitude of the magnetic field. Now this will give you the direction of the magnetic field. This will give you both the direction and the magnitude of the magnetic field. So this whole concept of vector product is heavily used in the 12th standard. Calculus is also extremely used. Yes, this law is universal. It is less, it is looking like Coulomb's law. You are right. It's mu naught, just as you have epsilon naught, which indicates the permittivity of the medium. Mu naught is a constant which deals with the permeability of the medium. Epsilon naught tells you to what extent, or epsilon tells you to what extent electric forces will be allowed. Same way, mu naught here will tell you to what extent magnetic forces will be allowed. Mu naught is the permeability of free space. That is, if you have free space, the permeability of free space. So mu naught is the permeability of free space. Its value is equal to 4 pi into 10 power minus 7. So I hope you are able to understand this, and then I hope you are able to understand this. Now I hope you understand what is this mu naught and what is epsilon. Okay. There are no three laws. There is only one law. The one law is that if there is a current carrying wire, around it there is a magnetic field. That magnetic field is equal to mu naught by 4 pi I dl cross r cap by r squared. So that is equal to mu naught I by 4 pi dl r cap is like 1 sine theta by r squared. This is the magnitude. This is the because of this cross product, it will give you the direction also. So they are not three different laws. They are different ways of writing the same law. That is one law. That one law is called the Biot-Savart law. So we need to learn how to apply the Biot-Savart law. Suppose there is a wire here like this. Suppose you are at some distance d. This is carrying a current I. You are here. If this angle here is theta 1, and if this angle here is theta 2, then for any element, please listen to me, this derivation is not there in NCERT. It helps in understanding. Okay, now suppose I take a small current carrying element. Suppose the current is going this way. So dl is in this direction. Now this is the r vector. This is the r vector. Yeah. So so this is the r vector here. Now I am interested in dB. dB is the magnetic field because of this small element. dB is equal to mu naught I by 4 pi dl cross r by r cubed. I hope this much you are able to understand. How did I write this? This I wrote by Biot-Savart law. Okay. Now, if you understand this, this is equal to mu naught I by 4 pi dl sine theta by r squared. Yeah. Now, how do you find out the direction? Stretch your right hand in the direction of dl, curl your fingers towards r, thumb points in the downward direction. So the magnetic field is in the downward direction. I'll keep doing that again. We have been doing this all the time. Stretch your right hand in the direction of dl, curl your fingers towards r, thumb points downwards. So the magnetic field is downwards. Now we want to know what is this theta. So this theta that you're talking of is this particular angle. the angle between dl and r vector. Okay, now if you understand this, this is what, this is dB. So this is the magnetic field because of that. Now let me see what I can do. So this angle here is 90 degrees. Yeah, this angle here is 90 degrees. Then this angle here is 180 minus theta. So together the two, or this particular angle here will be 180 minus 90 minus 180 plus theta. That's the small angle here. So this 2 gets cancelled. So it becomes theta minus 90 degrees. So that small angle there is theta minus 90 minus 180 plus theta. Okay, that is fine, no problem. So the small angle is this much. So sine of theta minus 90. Sine of theta minus 90 will become cos theta. So if this angle here is theta, then dB is equal to mu naught I by 4 pi dl cos theta by r squared. Do you understand this? Yeah. So if you understand this, then I'm okay with it. Yeah, so if you understand this, fine. Now dl can be written as r d theta. So dB will become equal to mu naught I by 4 pi. Instead of dl, I'm writing r d theta cos theta by r squared. Yeah, so one r here gets cancelled. So from here, if I integrate this, I will get the value for b. So that is equal to integral of this angle here is minus theta 2 to plus theta 1 mu naught I by 4 pi r cos theta d theta. Now, what is the integral of cos theta d theta? The integral of cos theta d theta is sine theta. So when I substitute, I will put it in red in the middle. So I'll get mu naught I by 4 pi r. Integral is sine theta, so I'm substituting. So it will become sine theta 1 minus sine minus theta 2. Yeah. Now sine minus theta 2 is nothing but minus sine theta 2. So ultimately, I will get, if there is a wire like this at this particular point, if this angle here is theta 1, if this angle here is theta 2, it carries a current. This is this. So it becomes mu naught I by 4 pi d sine theta 1 plus sine theta 2. So this is a very, very important concept. So mu naught I by 4 pi d sine theta 1 plus sine theta 2. Before you ask me any questions, first you think for a few minutes about it. DL is a differential length. It can always be written as r d theta. If you have, this is r, this is DL, so this is d theta. So DL is equal to r d theta. Always it can be written. Then sine of theta minus 90 is cos theta. Okay, so if you have made notes, then I will look at your questions and I will answer them. Yeah, sir, is it minus cos theta or cos theta? No, it is cos theta. Because I know theta is greater than 90 but less than 180. Greater than 90, less than 90, sine theta will be positive. So sine theta, yeah. So from there I can say that it is going to be positive. Sir, what we have found is only along X-axis. No, 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 no. I have a wire and I found out the magnetic field there. What is permeability? Permeability is the extent to which a medium gets influenced by magnetic forces. Just as you have epsilon, a constant in electrostatics, the same way you have mu, a constant in magnetostatics. What is mu? We will learn later. We don't need it now. Right now, for us, mu is just a constant. So it's not a dimensionless constant. It has a dimension to it. It is just a constant for us. Nothing more than that. Mu by 4 pi is a constant. But since you are asking and I know it, I am telling you that we will learn. Next chapter, when we go there, we will learn. We have to work out. Okay, we have to be a little faster. And you guys have to be working. I mean, I don't mind clearing doubts, but here, this angle is theta, suppose. Okay, then this angle is what? 180 minus theta. This angle here is 90. Now I'm asking you, how much is this angle? So this is a triangle. So you have 180 minus theta minus, this is 90 here, 90. So it will become theta minus 90. So this angle that you have here is theta minus 90. No, I'm sorry. Oh, okay. I can understand your query. Fine. No problem. I will explain again. I'll explain again. So this is a wire. This is a point where I want to find out the magnetic field. Suppose I take a small element here and I call this angle as theta. Okay, assume I put this angle as theta. If I applied Biot-Savart law, dB is equal to mu naught by 4 pi I dl sine of this angle. Let me call that phi. Sine phi by r squared. Okay. So if this angle here is phi, this is this much. If this angle here is theta, this is 90 degrees. Then what do we have? We have this angle here is 90 minus theta. So if this angle here is 90 minus theta, this angle here is 90 plus theta. So if you have sine of 90 plus theta, sine of 90 plus theta can be written as cos theta. So it will become mu naught by 4 pi I dl cos theta by r squared. Okay, this is a much better explanation than what I gave before. So if you may change it, I'll be happy about it. Yeah, this angle here is 90 degrees because I have just taken the perpendicular. This angle here is theta. Now this angle here will become 90 minus theta. So this angle here will become 90 plus theta. This is the direction of dl. dl is a element in the direction of flow of current. And this is the dr. I'm sorry, this is the r vector. So when you do cross product, you have to do the angle between them. So that is the angle between them. So that sine phi is equal to cos theta. So that is how I got it. Now I did what? I did mu naught by 4 pi I dl. dl was written as r d theta. Okay. Any dl can be, if this is dl, this is r. If this angle here is d theta, so it can be written as r d theta. So if I substitute, I'll get mu naught I by 4 pi d theta cos theta by r. Now the limits of my integral. So here I am going this way, here I am going this way, right? So the two angles that I am talking of, one side will be plus, one side will become minus. So I am talking about minus theta 2 to plus theta 1, because if one is plus, the other has to be negative, whichever way you take. So like this. Now the integral of this, all constants, all constant, all constant. So what is changing is going to be cos theta is going to change. So from there you can work it out. I've just done this simply. It is not 100% correct. There are some small errors in it, but I have just done it simply because we won't need this. We will never need this. We will only need the final conclusion. The final conclusion is B is equal to mu naught by 4 pi I sine theta 1 plus sine theta 2 by D. This is the only thing you will need. The derivation is not required. So the some errors in the derivation are okay. If anybody can catch the error, I will be happy. Okay, if anybody can catch the error, I will be happy. So this is how you can get the value for B. This is what we are interested in. Now this is the wire, this is the distance, and we are trying to find out the magnetic field at this point because of this wire. The direction of the magnetic field, stretch your right hand in the direction of current, curl your fingers towards the point, towards the R, the thumb points in the direction. So here the magnetic field is in this direction. Yeah, cos theta I explained to you correct. Limits from minus theta 2 to theta 1, that is also correct. Sir, 90 minus theta is cos theta, right? Yes. But there is sin 90 minus theta. Sin theta minus 90 is also cos theta, if theta is greater than 90. That is not the error, sir. So now because the thumb points into the page or the magnetic field is into the page, yes, it is circular. The field is downwards, yes. No, we have not found anything along the x-axis. We have found out on this side, on the right side. There is no y-axis. Okay, y-axis, yeah, there could be a field, yeah. So the magnetic field actually goes like this, and then it comes out. So on this side, the magnetic field is out of the plane. On this side, the magnetic field is into the plane. Okay, now for those of us who want to know what the exact error was in the work that I did. Oh, my goodness. Yesterday also I faced this problem. I lose my slides. Okay. So those of us who may want to make a note, please make a note first itself. This is slide 1. I have given you an assignment for 5 questions. It has to be submitted by tomorrow in STG. No sending me messages. Then this is slide 2. I'm talking about Biot-Savart law. This is slide 3. This is slide 4. Slide 5. Slide 6. Slide 7. Slide 8. Slide 9. So if this is a wire, on one side, if the wire current is going this way, on one side the magnetic field is inside, on the other side the magnetic field is outside. So the magnetic field goes this way. So magnetic forms circular loops around the wires. Unlike electric field lines which are not closed, magnetic field lines are closed. Electric field lines are not closed loops, but magnetic field lines are closed loops. Okay. Okay, good. It's mean the magnetic field is around the wire. Yes, yes. So now because the thumb points into the page, yes, the magnetic field is circular. Yeah, okay. So I made some minor errors there because I didn't want, I was feeling lazy about the differentiation in slide 2. My slides have come back. Okay, so I was feeling little lazy with doing the exact integral and differential. So this is how you can do the differential integral for those of us who know. Others, we will directly go back to the rule and we'll just apply the rule. Yeah, so none of this is there in your NCERT syllabus, so you don't have to worry. So this is D, this is L, this is DL, and I've joined this to this, right? So first understand this is root over of L square plus D square. So the way you will write Biot-Savart law, mu naught by 4 pi I dl sine theta, no doubt, by r squared. R squared will become L square plus D square. Yeah, where what is theta? Theta is equal to this angle here. So if this angle is theta, then you can write it this way. So I didn't write this L square plus D squared and all. I didn't write. I just simply assumed it is small and then I worked with it. No problem. So if this is theta, this is here 180 minus theta. Okay. So if you have sine theta, so okay. So this is 180 minus theta. This is 90. So this angle is how much? So this angle will become 180 minus 180 plus theta minus 90. So I can get rid of these two. So I will get theta minus 90. What I am trying to show is sine of theta minus 90 will be equal to cos theta. So cos of theta minus 90 will become equal to sine theta, right? So now because it is sine theta here, I will change it to cos of theta minus 90. Now if I change it to the cos of this angle, then my integral will look like L by L square plus cos of theta minus 90. Cos of this angle is L by this L square plus D square power half. So B will become equal to integral mu naught by 4 pi I dl into L by L square plus D square power 3 upon 2. Now you integrate this, you will get the value for B. Okay, now you give proper limits to this side and this side and you integrate, you will get. We don't need all these things. We just need to understand that if there is a wire and if there is a point here, if this angle here is theta 1 and if this angle here is theta 2, then B is equal to mu naught I by 4 pi D, if this distance is D, sine theta 1 plus sine theta 2. Okay, this is also not there in our book, but we will definitely need it for a lot of our problems, numericals, especially in the JEE mains. You will get a few numericals where we may need this. So it is advisable that we learn this. It is there in the state board textbook. So yeah, common minimum syllabus, it may come into it. So this is the only thing that I want all of you to remember. Assignment questions are there in STG. Magnetic field is a non-conservative force. As of now, yes. Magnetic field is a non-conservative force. Okay, so if you understand this, I am happy, we can move on. So now questions for you. Suppose there is a wire like this. This is an infinite wire. This goes this side, this goes this side. Now at a distance d, what is the magnetic field? So remember, we said B is equal to mu naught I by 4 pi sine theta 1 plus sine theta 2. So I am asking you, if it is going infinitely on both sides, what do you think will be the magnetic field? Now, do you, by D, do you get it is equal to mu naught I by 2 pi D? How did I say it is 2 pi D? Because if this is going to infinity, this angle here will tend to 90 degrees. If this is going to infinity, this angle here will tend to 90 degrees. So 1 plus 1 will become 2, 2 cancel, and you will get mu naught I by 2 pi D. Are you able to understand this? This is an important point, very important point. So the magnetic field at a distance d from an infinitely long wire is equal to mu naught I by 4 pi d. On one side, yeah, 4 pi becomes 2 pi, correct? Yeah. Yes, so if you guys are able to understand, I will move on. As of now, there are only 2 points I want you to know. Biot-Savart law is a 100% important question for your exam. Okay, earlier, no, some 2 years back, every year it used to come. Only last 2 years they have been changing little. They have not been giving, because they have not given. Next year when you are going to write, definitely you will get. So Biot-Savart law is an experimental law. You have to write this. This is there for 3 marks. Unless you draw the diagram, they won't give you more than 2 marks. That when a current passes through a coil, it induces, when a current passes through a wire, it induces a magnetic field around it. This induced magnetic field is proportional to the length of the wire, the current passing through the wire, the angle between the dl and the r vector, and inversely proportional to r squared. So dB is equal to I proportional to I dl sin theta by r squared, equal to mu naught by 4 pi I dl sin theta by r squared. This is Biot-Savart law. Okay, so this is very important. So now after that, the next thing that is important is this particular formula, and the application of this formula we are going to see a few cases right now. So this is how magnetic fields are created. Magnetic fields are created when electric current passes through a wire. This is, soon it will become electromagnetism. Mu naught I by 2 pi d. B is equal to mu naught I by 2 pi d. Okay, sir, in both also we don't want the derivations. No. This derivation is not there. How to upload homework in STG? I will show you at the end of the class. I will show you. Boards, you do not get derivations, you get applications. Okay, so we have to learn applications. We don't have to learn derivations. Okay, so if it is understood, then we will move on. So there is one more application. Where is my, yeah. So there is one more application of this, which I would, one more question I will ask, then I will take you to one more application. Suppose this is a wire. Wire current is going this way. At this point, can you tell me what will be the magnetic field? This is like this. At this point, can you tell me what will be the magnetic field? First thing is, when the current was upwards, the magnetic field was inwards. When it is like this, the magnetic field will be outwards. The magnetic field will be outwards. Then it will become what? Mu naught by 4 pi I sin theta 1 plus sin theta 2 by d. Yeah. Now sin theta 1 will be 0. Sin 0 is 0. So this will not come into play. This will become 90. So it will become mu naught I by 4 pi d. So the magnetic field B is equal to mu naught I by 4 pi d. So that is how you can find out the magnetic field at this point. So if you get this, then we are a step closer. So we will do a little bit more theory and then we will come back. Yeah. Okay. The next question. This is also, this is important. This is important. There in text. THERE, there in the text. Asked several times. Okay. So this is asked several times in your exam. in the NCERT exam. Now I am asking you this. Suppose I have a coil of wire. Okay. Suppose I have a coil of wire. Now this is the axis. At this point, I am asking you, what is the induced magnetic field? Suppose this is carrying a current like this. I am asking you at this point, what is the induced magnetic field? Okay. Now, suppose this radius here is equal to A, and this distance here is equal to some x. So this will become root over of a square plus x square. Yeah. Now current is going this way, so you have a tangent here. You have a tangent here. Yes. Do you understand this? Then do you understand that this is dl vector? This is dl vector. This is r vector. So do you understand that db vector will be like this? db vector will be like this. This is dl. This angle here will be 90 because it is the tangent to the coil. Yeah. So that is in a different plane. This is in the xy plane. This will be along the z axis, rather the along the z axis, and everywhere else it will be in the yz plane. So it will be perpendicular to that. And now this is going to be the db. Are you able to understand this diagram? Can you draw this diagram? What is your question? Where is your question? Nilan, ask me again. That is easy. Gokul. Sir, we must learn all. No, sir. But Nilan, ask me again. How did we get the direction of dB? dB is perpendicular. I applied the right hand rule. So I want you to apply the right hand rule. What is the direction of the magnetic field? Direction of the magnetic field. Stretch your right hand along the direction of current. Curl your fingers towards B. The thumb will point in the direction of the magnetic field. Yeah, Nilan, what is your question? Not able to see it. Type again, please. Sorry, I missed it. Yeah, so direction of dB, I hope you are able to understand. Take your right hand, put it in the direction of current, curl your fingers towards the R vector. The thumb will point in the direction of B. So the right hand rule that you learned in the last class will tell you. Where is? Hi sir, good afternoon is the only thing that I see from him. Amrish, Apurva, Hayak, Hari, Abhishek, Apurva, Supiksha. Sir, is it Biot-Savart Law or what is the difference? Yeah, Biot-Savart are the names of scientists. Yeah, they're two different people. Would we also work in curved wire? We would also work in curved wire? Yeah, we will work. We will. Oh, A. If I wrote E, I'm sorry about it. It is a A. It's a name of a person. Direction of B, you can't get it. Okay. Direction of B, you can't get it. See, first, understand that it's a coil. So stretch your fingers. Okay. Let me try to do it on a video. Let me try to get the video on, and then let me try to do it. Okay. So here is the video. Yeah. Where is the video? You are able to see, but I am not able to see what I'm showing. No, only if I see what I'm showing, I can show it correctly. Okay, yeah. So here, yeah. So see, if you have to use the right hand rule, then what is going to happen? What is going to happen is this: that you are going to you're going to put it this way. Yeah, this is you're going to put it this way, and then you're going to incline it because see, the tangent is like this. Okay, see, the r vector, the L vector is this way. Okay, the L vector is this way. The other vector is going to come like this. The DL vector is here. This is the R vector. This is the R vector. So this is, do you see that this is at an angle? Okay, so now it is going to be perpendicular to this. So this is how the DB vector will be, perpendicular to both. Here, this is the DL vector. Okay, now this is the R vector. Yeah, so now it is going to be perpendicular to this. So perpendicular to this will be this way. So that is what I have drawn. Yeah, so it works out. Sir, if you stop screen sharing, we can see properly. But your network bandwidth is low. Only screen is visible. That's what I wanted you to see. Okay. Okay. Okay, you guys are experts in all this, right? Okay. So see, see this is the radius. I mean, this is the circle. The circle is like this. In the vertical plane, the circle is coming. So this will be the DL vector. This will be the DL vector. Now this is inclined. It is not straight. Inclined. Inclined will be the DB vector. Yeah. So the DB, inclined is the R vector, R. So now when I come to the elbow, at the elbow, perpendicular to the elbow will be the DB vector. Yeah, this is as much as I could explain. So let me know whether you understand or no. So you go back and then you look at my diagram again, then you'll understand it better. See, I have to think of something which is perpendicular to this. Okay. So perpendicular to this, see, this is the x-axis, this is the y-axis, this is the z-axis, right? So this is in the yz plane. Yeah. So perpendicular to the yz plane is the xy plane. Yeah. So I have to be on this. Then because I am doing dl cross l, so I have to think of perpendicular to this. I thought now I have to think perpendicular to this dl cross r. Now I have to think perpendicular to the r. Perpendicular to the r is going to be this. Yeah. Now do you understand? Please put some messages. Yes, Subiksha, Anirudh, Jafran. Yes, we are able to see. Direction of B. Sanjana, are we getting this? Okay. Okay, fine. Okay. So if you are getting it, then we will proceed from there. But this is important derivation. Okay. So this diagram is very, very important. So now if we apply Biot-Savart law here, I'll get dB is equal to mu naught by 4 pi I dl cross r cap divided by a square plus x square. Okay. So this much all of you understand. So now this will become equal to, see this angle here is 90 degrees. So the cross product is already done. So it will become equal to mu naught by 4 pi I dl by a square plus x square. Now understand that when I look at another element here, its magnetic field will be like this. And so, and that magnetic field here will be sweeping a cone. That magnetic field will be sweeping a cone. How do I say that? It will be sweeping a cone. Let's look at this. So the way it will work out is this. I have this. So for one, it will be, okay. So for one, it will be like this. For the opposite end, it will be like this. As I move in a circle, it will keep going this way. So do you see that here it is going to sweep a cone? Yeah, as I keep changing my hand, rotating my hands 360 degrees, it will be sweeping a cone. So the magnetic field there sweeps a cone. Yeah, so the magnetic field here sweeps a cone. When it sweeps a cone, there will be a y component and there will be an x component. The y component will cancel and there will be only an x component. And the x component will become into, if this angle is theta, like this is 90, so this should be 90 minus theta. We are talking about cos theta. So I'll take it here, it will become, if this is cos theta, here it will become sin theta. So cos theta will become equal to A divided by 3 by 2. Yeah. Now, when I integrate this over the full loop, everything is a constant here. Nothing is changing. So the dl will become 2 pi A. So finally, I will get B is equal to mu naught by 4 pi I. dl will become 2 pi A square divided by A square plus x square power 3 upon 2. So the 2 pi will get cancelled. So finally, ultimately, I will get mu naught I by 2 A square by A square plus x square power 3 by 2. So this is the magnetic field at a distance x from the current carrying loop along the axis of the loop. Yeah. Yes. So if you can understand, please spend a few minutes and try to write it down. Once in your own words you write down, again I will explain. In your own words you please write down and then again I will explain. Okay, or what we will do is, don't worry, next class we will start from here. Okay, till then please rewrite your notes here. I'll show you what all we did today. So here is the first one. So this part, slowly now we have come to electromagnetism. There is the scientist by the name Maxwell who has contributed a lot to this. Ampere as a scientist has contributed a lot to electromagnetism. Biot and Savart, both of them have also contributed. Lawrence has also contributed. These are all names of scientists. Like I say, whole of the 12th is experimental physics. Right now what we are doing is 1840, 1850. And one person who made maximum applications out of all these theories was Edison. This is the 7th slide. Eighth. Most of these studies happened in Europe. 9. Edison was in US. 10. 11. 12. Understand that most of the Americans who made it big were not the native Americans. They were the Europeans who had gone and shifted to America. 1830, 1840, 1850. Around that time, America was discovered. I think started inhabiting it somewhere around 1700s. So now, given that they had so vast resources and it was a rich country. A lot of these rich Europeans shifted from Europe and then went and set up base in the US. But the real scientific community started shifting to US after Hitler came. That was 1900, 1920, 1930, peak at 1940. Okay, so how to upload your homework? Okay, y is cos theta a by, isn't it the difference between the point and the loop divided by r? Y is, one second, y is cos theta a by and power half, isn't it the difference between, no, cos theta, okay, next class we will do. I'll teach you first how to upload, I will do cos theta, this angle is theta, so this angle is theta, so this angle here is 90 minus theta. So if you're talking about cos theta, you will talk about sin theta. Sine of this is a divided by this. You are talking about this angle, though, that is a d theta, that is not theta, that is d theta, but here we are not using d theta or anything. Okay, for you to log in, first open some browser, or open Google Chrome to be better. So go to stg.learnity.com. So once you go there, you will apply your login details. Don't apply my login details. Yeah. Once you go here, then there will be one assignment. So let us look for an old assignment. I will look for an old assignment and search for one. Wait. I'll get one assignment. In a minute, I will get one assignment. Hang on. I'm not able to find one. Trigonometry. Okay, in this place, no, you will get one assignment. Okay. Once you get one assignment, at the top, you will get one small clip. You click on that clip. If you click on that clip, you will be able to upload it. Yeah, I got an assignment. Oh, why? I got your assignment itself. 12th assignment, neat. Assignment 12th, neat. Magnetic forces. This is an assignment. No. This is not an assignment. Okay. This is not an assignment. Anyway, wherever you get an assignment, no, on the right side, you will find a small clip. So if you click on that clip, you will be able to submit it. Okay, so I gave them the assignment now. They will be putting it. These are all your old JEE classes. This is online JEE class, July 1st. Okay. So anyway, now here you will get it. Once you get it there, you check and then you let me know afterwards. Then maybe tomorrow I'll teach you how to upload it. By tomorrow it will be there. Yeah, okay. But there are a lot of videos for you on this chapter. Those of us who are missing classes may want to go there and then learn it. The whole of this chapter is beautifully explained. Here there are so many videos: galvanometer, conversion to ammeter, magnetic force due to straight and bent wires. Then again here you have application of Ampere's law. This is on NEET. If I go to NCERT, there'll be few more videos here. So I have solenoid toroids, magnetic field. This is Biot-Savart Law, Aristotle's experiment. Lot more videos are there here. You can work on them. Yeah. Okay. Bye. Yeah. So if you can see that, that's where you have to know more history. I love history more than science. Okay. Bye. These guys also know they have to comment saying that, sir, you